Hey there, and welcome back to the channel. If you've ever wondered how to actually use a multimeter and why it's so important for working with electricity, you're in exactly the right place. And if you're new here, make sure you subscribe because we're breaking down electrical concepts that'll make you feel like a pro in no time. Today, we're going to demystify the multimeter, one of the most useful tools you can have in your toolkit. So stick around as we dive deep into how this incredible device works and how you can master it. A multimeter is basically your best friend when it comes to electrical troubleshooting. It's a single handheld device that can measure multiple different electrical properties, which is why they call it a multimeter. Think about it like having a Swiss Army knife for electricity. Instead of carrying around 5 different specialized tools, you've got one compact device that does the job of several instruments rolled into one. The really cool thing is that multimeters have been around for decades, and they're used by electricians, engineers, and hobbyists all over the world. When you're holding a multimeter in your hands, you're holding a tool that can tell you everything you need to know about what's happening in an electrical circuit. Now here's my first question for you, so pause the video and answer this in the comments. What do you think is the most important measurement a multimeter can take when you're troubleshooting an electrical circuit? Let's think about that while we move forward. A multimeter typically has 3 main measurement capabilities. First, it can measure voltage, which is the electrical potential difference between 2 points. Second, it can measure current, which is the flow of electricity through a conductor. And third, it can measure resistance, which is how much a material opposes the flow of electricity. These 3 measurements form the foundation of electrical diagnostics, and understanding them is absolutely crucial. When you understand voltage, current, and resistance, you unlock the ability to diagnose problems that would otherwise seem mysterious. Let me explain voltage first, because it's probably the most intuitive. Voltage is like the pressure in a water pipe. If you have higher pressure, the water flows faster and with more force. In electricity, higher voltage means there's more electrical potential pushing electrons through a circuit. Your household outlets in the US provide about 120 volts, while larger appliances might use 240 volts. Industrial settings can go even higher. Understanding the voltage in a circuit helps you know whether a device is getting the power it needs to operate correctly. If you tested your household outlet and got a reading of 110 volts instead of 120, what do you think might be causing that? Pause and tell me your answer in the comments below. Now let's talk about current, which is the actual flow of electrons through a circuit. Current is measured in amperes, or amps for short. A small LED might only draw a few milliamps, while a microwave might draw 15 amps or more. This is critical because too much current flowing through a wire creates heat, which can damage insulation and cause fires. That's why circuit breakers and fuses exist. They're designed to cut off the current if it exceeds safe levels. When you use your multimeter to measure current, you're actually inserting it into the circuit path, which is different from how you measure voltage. This is a really important distinction that we'll get into more detail about very soon. The third major measurement is resistance, which tells you how much a material opposes the flow of electricity. Resistance is measured in ohms, represented by the Greek letter omega. A perfect conductor has nearly 0 ohms of resistance, while an insulator has very high resistance, sometimes in the millions of ohms. When you're troubleshooting, measuring resistance can help you identify broken components or faulty wiring. A burnt-out resistor might show infinite resistance, while a shorted component might show nearly 0 resistance. Here's my third question, and this one's important. In what situations would you want to measure the resistance of a component, and why would you unplug the device before doing so? Think about that and drop your answer in the comments. Now, let's get into the actual physical anatomy of a multimeter, so you know what you're looking at when you pick one up. The front face of a multimeter has a large dial or display that shows your measurements. Older analog multimeters have a physical needle that moves across a scale, while digital multimeters show the measurement on a screen. Digital multimeters are far more common today because they're easier to read and more accurate. Below the display, you'll find a rotary selector knob with lots of different settings. This knob is your control center. You rotate it to select what you want to measure: voltage, current, or resistance. But here's where it gets interesting. The voltage setting usually has 2 options: DC voltage and AC voltage. DC stands for direct current, which flows in one direction, like in a battery. AC stands for alternating current, which constantly changes direction, like in your household wall outlets. You need to select the right one, or your reading might be completely wrong. The back or sides of a multimeter have ports where you plug in the test leads. The test leads are those two colored wires with metal probes at the ends, usually one red and one black. The red lead is positive and the black lead is negative or ground. These aren't just arbitrary color choices. The colors follow a standard convention that electricians and engineers use everywhere. That consistency makes it easier for anyone to pick up a multimeter and understand the setup quickly. Here's my fourth question. Why do you think the red and black color convention exists for electrical testing equipment? And do you think it matters? Tell me your thoughts in the comments. So here's how you actually use a multimeter to measure voltage. First, you select the correct voltage setting on the dial. That's AC voltage. If you're measuring a battery, that's DC voltage. Then you insert the black probe into a ground or neutral point, and you insert the red probe into the point where you want to measure the voltage. The multimeter will then display the voltage between those 2 points. And here's the beautiful part. Measuring voltage doesn't interrupt the circuit or damage anything. You can safely measure voltage while the device is running. This makes voltage measurements incredibly safe and non-invasive. Measuring current, on the other hand, requires you to break the circuit. You've got to physically insert your multimeter into the circuit path so that the current flows through the multimeter itself. This is more complicated and requires more care, so it's something you should practice carefully before attempting on real circuits. Measuring resistance is done on components that are isolated from the circuit, typically with the device unplugged. You touch the two probes to opposite ends of the component, and the multimeter applies a small test voltage to determine the resistance. Never measure resistance on a live circuit, because the multimeter's internal batteries could interact dangerously with the live circuit. When you first pick up a multimeter, the sheer number of settings can feel overwhelming. But here's the secret. You don't need to use every single setting right away. Start with the basics. Learn how to measure DC voltage, then AC voltage, then resistance. Once you're comfortable with those, you can explore the more advanced features. Most multimeters also have a diode test setting, which helps you check if a diode is functioning correctly. Some have temperature measurement capabilities or frequency detection. But for 90% of the troubleshooting you'll only need voltage, current, and resistance. Here's my fifth and final question for you. What's the first electrical project or repair you'd like to tackle if you felt confident using a multimeter? This is genuinely something I'd love to hear about, so please pause and share your answer in the comments. Let me give you some practical safety tips before you start using a multimeter. Always check that the probes are in good condition. Cracked or damaged insulation can cause electrical shock. Never measure voltage on circuits that exceed the maximum voltage rating of your multimeter. Most handheld multimeters are rated for 600 volts, but some measure higher. Always wear safety glasses when working with electrical circuits, not just because of the multimeter, but because electrical work in general has hazards. If you're not sure about a circuit, don't measure it. It's better to be cautious and ask someone with more experience. Never leave a multimeter set to measure current and then connect it across a voltage source. This will create a direct short circuit and destroy the multimeter. That's a mistake you only want to make once, and preferably not at all. Keep your multimeter in good condition. Store it in a dry place, avoid dropping it, and replace the batteries regularly. A multimeter is an investment in your ability to understand and work with electricity safely. When you're just starting out, it might feel like there's so much to learn. But honestly, the basics of multimeter use become intuitive pretty quickly. After you've measured voltage a few dozen times, you won't even think about it. It becomes as natural as using a thermometer. The real skill comes from knowing what to measure, where to measure it, and how to interpret the results to diagnose problems. That's where experience comes in. Every time you use your multimeter, you're building that skill and confidence. I really hope this video has helped demystify the multimeter for you. If it did, please hit that like button because it genuinely helps us create more electrical education content for you. And seriously, if you haven't subscribed yet, this is the perfect time. We're constantly putting out videos about electrical concepts, DIY projects, and troubleshooting tips that'll help you become more confident working with electricity. So go ahead and hit that subscribe button and ring that bell notification so you never miss a video. Remember those 5 questions I asked throughout the video. Head down to the comments and answer them. I genuinely love to know what you think, what you've experienced, and what you want to learn next about electricity and electrical tools. Your comments help shape what we create next, and they help other viewers learn from your experience too. Thanks for watching, and I'll catch you in the next one.